That looks good. Let me go ahead and share. Where is it? This one. Let me share. This one. Share. And like, cause I was like, okay, when I saw that, I was like, okay, well, let me remove the thing where, let me change the settings so that I can boot people and they can get back in. Okay. Oh, so let's see. Actually, I need to change that. Let's close this out. I need to open up this. Okay, let me finish getting things set up. Hang on. Oh. I'm recording. So, yeah. All right, thank you. Let me see, I'm going here. No, but yeah, you got it because she's gonna be moving in, so you want to just be careful about just you know. I'm streaming too, so yeah. So okay. Ma, I was gonna say you might want to use the other one. The other one has toilet paper. Okay, come on. I think this is the right one. This looks right. Let's log in. So we're in section 2.3. And let's do one other thing. Manage. I want to copy it 2.3 because that's where we are. Yeah, so here, let me just go ahead and open up this because I know that's what I need to do. Do I have it? No, I don't have a copy, so let's go ahead and make a copy. Let's copy this. And I just want to save it. That's fine. And then let's go here. We got to change this. So I want to stop sharing. And let's do this. We need to share the desktop. Share. Okay. So so we finally got started. Let me see. Make sure we're streaming. Let me check the stream. So that's what that's showing. Okay, that's fine. Let me go ahead and open up this so it'll display properly. Don't start. No, thank you. Don't start. Like it was nice and quiet. Let me see. I just want to preview. And come on. Come on. Full screen. Man, it's like moving so slow today. Okay, let me try this one. Okay. And then if I go here and do like this one, it should show it. Nope, that's not right. Like this. There it is. Okay. All right. So, all right. Let me see. So, okay, let's hop over to. Oh, I can't see it here. Well, let me just talk about it. So, let me see. We've completed chapter 2, sections 2.1, 2.2, and 2.3. This is week 11. So next week will be week 12. So every 4 weeks we have an exam, right? It's not too. I mean, I don't know what you guys experience on your end. I know it's not the same as like a regular exam, like a testing environment and all that, but you know, it's a little bit different format. But it should open up next Wednesday, right? So exam 3 over chapter sections 2.1, 2.2, and 2.3. that'll open up next Wednesday. So we're just gonna devote that whole week to just reviewing stuff, like all of chapter 2. Today we're gonna focus on 2.3, and it's just a little bit better if you come with questions. Else I just kind of go over like random questions. I might take some more time next week to review some factoring techniques. But today we'll go through section 2.3. We can try some factoring tomorrow. Exam 3 is next week. And then after that, I think we have 2 sections remaining. I think it's like section 3.1 and section 6.4. And I think we're going to do both of those sections. Maybe we'll go ahead and do section 3.1 next week instead of trying to jam those into the last 2 weeks. Into the last week. So we'll probably do 3.1 next week just to keep everything spaced out. And then we can do 6.4 the following week. And then I think the week after that is the final exam, right? So if this is week 11, that's 12, 13. I think it's 14 weeks total, right? We're gonna have taken the final exam before we go into the Thanksgiving holiday. So once you're at Thanksgiving, you'll already be done with this class, and just like that, in the blink of an eye, it's over, right? Finish him, right? So hopefully, I just say that to say hopefully we're getting our Pearson in order. Our grade from this class is 90% Pearson, so pretty much the grade you see in Pearson is essentially the grade that you'll have. And then 10% will come from Alex participation. I'm just going to kind of check it, and it's not going to be a 100% completion grade, but you'll get most credit as long as you show some evidence of having used Alex. Like, I'm not going to make too big a deal about it. But, the main thing is we need to be working our way through Alex. My colleague does send me the reports on a weekly basis. The main thing is you just want to have evidence that you've been working in Alex, and that'll be enough. So 90% is Pearson, 10% is Alex, and that'll close us out. We'll be able to finish things out. I probably will recalculate the grades because I think my grading scale is a little bit different than the way I have it set up on Pearson. I think I have to check the syllabus, but the homework might be like 10, maybe 15%. Usually what I do is homework is 10%, quizzes are 10%, and the exams are like 80%, So I have to look and see what I have in the syllabus, and I might readjust things. So I say that to say, if you're like completing work or like going back over old assignments on Pearson, I see my signal's a little bit weak. If you're going over old assignments on Pearson, I didn't realize I was sharing. Let's go like this. If you're going over old assignments on Pearson, I would definitely target the old exams first, right? Like, you just want to make sure your exams are whatever grade you want, that is there. Because those are usually a heavier weight than the homework. The homework is a lot of work for a little bit of points. Oh, I forgot. We have people there. I totally forgot about that. Let me go ahead and let them in. So let's go like this. Yeah, okay. Let me let these guys. This one. Let's do this one. Come on. You acting up now? There we go. And I think he was in and just got out. Okay. Okay, that's fine. Okay. So, and let me go ahead and load the chat. I'll monitor the chat. Let me see. Yeah, I'll be monitoring the chat. If you have specific requests, just feel free to load them in the chat or unmute yourself. Let's hop over to Pearson. And kind of start making our way through some of these questions. Okay. So yeah, let's just do as many questions in section 2.3 as we can, and we'll take notes and write things down as needed. We'll go paper, graph paper. Okay. This all looks okay. So we're actually using synthetic division to find the quotient and the remainder when the first polynomial is divided by the second. Okay, this will be fun. So this will be some good practice. Okay. So I'm going to take some notes here. So this is homework. Let's just do like this. This is section 2.3, dividing polynomials. Homework. Hopefully you guys have voted if you have the opportunity to vote. Okay. And this is question number 1. It comes from section 2.3, number 1 from the back of that section. We're doing synthetic division to show, okay, so we have 2x to the 5th plus x to the 4 minus 7x cubed plus 2x squared minus x plus 1 divided by x minus 1. Okay, let me show what I'm writing. I got this, and let me do like this so it'll show here. Awesome sauce. Okay. All right, so we want to do synthetic division. So when we do synthetic division, one thing is that every exponent needs to be accounted for. If we're missing an exponent, as we count down, then we need a placeholder. So we have 5, 4, 3, 2, 1, 0, right? So every exponent is accounted for. The second thing is that the proposed 0 from here needs to go into the chair, right? So since we have x minus 1, that means 1 goes into the chair, right? Because if we plug in 1 there, it will give us 0. So now we just take the coefficients. The coefficients are going to be 2, 1, negative 7, 2, negative 1, and 1. All right? So then the first term comes down. On the diagonal, we multiply. Vertically, we add. Diagonal, we multiply. We add. We multiply. We add. We multiply. We add. We multiply. Did I make a mistake? Let me see. Maybe, maybe not. So this is not a 0 because the remainder is not 0. Right? So 2. 2 plus 1 is 3. That's going to be a negative 4, negative 2, negative 3. Okay. Let's see. So let's see what it is. Let's go. Let's hop back over. Okay. Let's go like this and like this. Oh, so the quotient and remainder, right? Let me show this really quickly. So because we started with the degree 5 polynomial, this part here is called the depressed equation. And so because we started with the degree 5, that means the depressed equation is now going to be a degree 4. So this is going to be 2x to the 4 plus 3x to the 3rd minus 4x squared minus 2x minus 3. And negative 2 is our remainder. So that's what we're going to type into Pearson. Let's hop back over to Pearson. All right, so then here, we got 2x to the power of 4 plus 3x to the power of 3 plus, no, minus, stop doing that. Is that an exponent? Why does that not look like an exponent? Okay. Minus 4x squared, 4x to the power of 2. Oh, maybe it's because we're zoomed in. Whatever. I'm going to let it be for now. Squared minus 2x minus 3. And the remainder, I guess we just put negative 2. Okay, let's see how do we do it. Okay, so that was that one. Use synthetic division. Okay, let's do this one. These go fairly fast, and I enjoy them. So this is question number 2. Number 2. This comes from section 2.3, question 5. Okay. Synthetic division. So we have a negative 1 in the chair. Oh, actually, before we just let's get a copy of the original. So we have this x to the power of 6 plus 4x to the 4 minus x cubed plus 4 over x plus 1. Right? So let's hop over to the tablet. Okay. So we're going to do synthetic division. We definitely are missing some of the exponents, so we're definitely going to need some placeholders. Okay. So in the chair, in this case, is going to be negative 1 is going to go into the chair. No. Thank you. You going to help me out? You going to help us do this work today? Thank you. Thank you for helping us. What you going to do? I need you to make a decision. Okay, thank you. So now. So, yeah, we need some placeholders, right? Okay. So it looks like we're missing a degree 5. So we're gonna need a placeholder here. Let's Let me see how I'm going to do this. So the leading coefficient is a 1, but then degree 5 is missing, so we need a placeholder there. 4 is there, so that coefficient is 4. Then we have a negative 1. Squared is missing, so we need a placeholder there. I think the power of 1 is missing as well, and then we have the 4. So it looks like we needed 3 placeholders. If we have 6, we should have seven numbers. 1, 2, 3, 4, 5, 6, 7. Okay. All right. So then, oh no. Are you gonna need some juice? Okay, let me get my chart here. So many things that have to be charged for this stuff to work properly. I need to call her and check on her too. Alright, so you just hang tight. Hang out right there. Okay. So now let's do our synthetic division, right? So again, the first one just comes down. On the diagonal, we multiply. So negative 1 times 1 is negative 1. Then that adds to negative 1. 1, 5, negative 5. Negative 6, 6, 6, negative 6, negative 6, 6 plus 4 is 10. Okay. So I think we're doing the same thing. So since we started with the degree 6, this is now a degree 5. So we have x to the power of 5 minus x to the power of 4 plus 5x to the power of 3 minus 6x squared plus 6x minus 6, right? So that's, and the remainder is 10. So that's what we're going to type into Pearson. Oh, and while I'm doing this, I can give you a chance to try. Thank you. I knew she was going to do that. She just wants some attention. Oh, okay. So let's hop over here. Yeah, and then here. Okay, so let's type in what we just found. We have x to the power of 5 minus x to the power of 4 plus 5x cubed plus 5x to the power of 3 minus 6x squared minus 6x squared plus 6x minus 6. Okay, blah, blah, blah. Do not factor quotient and the remainder. So if we want to include the remainder, we got to do plus. Oh no, no, what's going on there? Okay, the top is our remainder, which is 10, and the bottom is the divisor, right? X plus 1, this thing, all right? Okay, let's go with this. Let's check. Let's run it back. Let's see what did we do wrong. Quotient and remainder. We got x to the 6 plus 4x to the 4 minus x cubed plus 4. We need to have 7. We got a 1, 0, 4, negative 1, 0, 0, 4, right? Negative 1 is a 0. Oh, the quotient. Okay. I included the remainder in there. I think it's going to be a separate question. So let's get rid of the remainder and just put the quotient. And then the remainder is 10. So that we just didn't do the right formatting. Okay. Okay, that was fun. We were about to waste a lot of time trying to find that mistake, but that's okay. Use synthetic division to find the quotient and remainder when this polynomial is divided by that one. Okay, let's do this one. So this is, let's just get some clean space. This is number 3. This comes from 2-3, question number 7. We have this 5x cubed plus 8x squared minus 2x plus 1 is divided by x minus 1 over 5. Okay. tablet. Okay. Yeah, the remainder is separate. Yep, you guys are right. Okay. Synthetic division. So the proposed zero in this case is 1/5, right? So we just do the same thing and it should be fine. We need to make sure every exponent is accounted for. We got 3, 2, 1, 0. So the exponents are fine. We don't need any placeholders. So then we just take the coefficients, 5, 8, -2, and 1. Okay. So again, the first one just comes down. That's going to be 5. If we multiply, we get 1. We add, we get 9. We multiply, we get 9. Nope. We get 9 over 5. I think that's going to be, what, a -10 over 5? -10 plus 9 is -1 over 5. And then we're going to get a -1 over 25. 25 minus 1 is 24, so that's going to be 24 over 25. Okay, so since we started with degree 3, this is now a degree 2. Okay. This should be okay. Okay, let's go with this. Let's see what happens when we use this one. Let me put my pen back on the charger. Let's hop back over to Pearson, and let's see the quotient. So we get 5x squared plus 9x minus 1/5. And then the remainder, 24 over 25. Okay. Synthetic division. Okay, I don't mind. Let's do another one. So we got 4. Oh. Nope. Redo. There it is. Okay, so this is question number 4. This comes from 2-3, question number 9. We got 2x cubed minus 5x squared plus 2x plus 2 over x plus 3 halves. Okay, more fractions. Awesome. Hop over to the tablet. Like this. Okay. So if we're going to do synthetic division, here, -3/2 goes into the chair. Hang on, I gotta make sure this door is closed. Is the lounge now? Cool beans. Happy for her. Okay. Let's see. Make sure every exponent is accounted for. 3, 2, 1, 0. So we're in the clear there. So we just take the coefficients. We have 2, -5, 2, and 2. Right? Again, the 2 comes down. If we multiply, we get -3. That adds to -8. That's going to be 4 times 3 gives us a positive 12 in this case. 12 plus 2 is 14. 14 divided by 2 is 7 times 3. This is going to be a -21, and it adds to -19. Okay. Fortunately, we didn't finish with any fractions. Since we started with degree 3, this is now a degree 2. 8x plus 14. So let's give this one a go. Okay. Hop back over to Pearson. So the quotient, we got 2x squared minus 8x plus 14, and the remainder is -19. Next question. Synthetic division defines this for the given value k and a function p. P of k, right? So if we want to find p of k, we just put k into the chair. We just use synthetic division. So it's the same thing that we've been doing. So if we do number 5, oops. So this is number 5. This comes from 2-3, number 11. It says that k equals 4. we got P of X equals X cubed minus 2X squared plus 8. And we're asked to find P of K. Okay. So let's hop over here. And here as well. Okay. So if we want to find P of K, then all we have to do is synthetic division where K goes into the chair. All right. So then we're going to say 4, and the coefficients, let me see. First, let's look at the exponent. We go 3, 2, we're missing a 1, so we need at least one placeholder. So we have 1, negative 2. This is where we need the placeholder. And then I think we have our constant term. Okay? So then the 1 comes down. 4 times 1 is 4. That adds to 2. That's going to be an 8. 8. 4 times 8 is, I don't know, 32. And it adds to 40. Right? So then that means that P of K equals 40. Let this charge a little bit. Okay, so we're going to hop over to Pearson, and P of 4 should be 40. Let me take this off. All right, you're free. All right. Let's do the next one. City now. I might go down there. I might go Bargum. All right. Let's see. This is number 6. Synthetic division. Let's do it. I mean, these are to me this is light, right? You know. 6 or 7. Cool beans. I'll get over there sometime. I might do some drugs. Anyway, I'm totally in my mind. Let's see. Number 6. So this comes from section 2-3, number 13. We have f of x equals x to the 4 plus 3x cubed plus 6x squared minus 2x minus 3, and we're asked to find f of 7. Okay, let me shrink this down just a little bit. Put this where I want it to be, and then put it back. Let's go like this. That looks decent. Okay. So let's hop over here. What am I looking for? Oh, like this. Okay. All right. So we're asked to find f of 7. So we do the same thing. Put 7 in the chair. Do synthetic division. Oops. 7. Let's make sure all the exponents are accounted for. So it goes 4, 3, 2, 1, 0. So all the exponents are accounted for. So we take the coefficients. 1, 3, 6, negative 2, negative 3, right? It's 5. 1, 2, 3, 4, 5. Okay. So then the first one just comes down. We get 7. That's a 10. That's 70, 76. 490. I don't know. Hey Siri, what's 76 times 7?
76 times 7 is 532.
So then that's 530. I'm going to do some multiplication here. That's a 0. 7 times 3 is what? 1 carry the 2. 35, so 37. Minus 3 is 3707. Okay. All right. Well, let's go with it. That's what we got. I think we want f of 7, so the 3707. Let's try the 3707. Let's see, 3707. That's not an O. 7. All right, there you go. Use the factor theorem to determine whether the first polynomial is a factor of the second. Okay. Stopping at honey bubble. Oh, I'm so there. Oh, I gotta get out of here. It's such a beautiful day. They hit up all the old spots. Oh my goodness. I gotta turn that off. It's so distracting. All right, number 7. Number 7. Oh, she don't have to stay here because she'd be all in the way. 2.3. This comes from section 2.3, number 15. It says use the factor theorem. So we have this x plus 5 divided into, we have this x cubed plus 8x squared plus 11x minus 20, right? Let me see. So if we want to know if that's a factor, that means when we do synthetic division with negative 5 in the chair, if we get a remainder of 0, that means it's a factor. Okay, let's hop over to the tablet and let's do the work, right? So again, this means that negative 5 goes into the chair. Let's make sure our exponents are accounted for. 3, 2, 1, 0. So we're good to go on the exponents. So then we take the coefficients of 1, 8, 11, and negative 20. Okay? The 1 comes down, multiply this to negative 5, add, what is that, 3? It's going to be negative 15. That's going to be what? Negative 4. That's a positive 20, and yay, we got a 0. So that means yes, it's a factor. Let's hop back over here, like this. Is it a factor? Yes, right? See, we could have guessed on that, and we would have a 50-50 chance of it being correct, but then chance favors the prepared mind, right? Okay. Factor theorem, synthetic determinism. Okay, same thing. This is number 8. What was this one? So this is number 8. 2, 3, number 17. So we have 3x to the 4, 12x cubed, 3x squared, 64x. 16 divided by x plus 5. Okay. Oh, and you need to be able to see this. We want to know if it's a factor, so it's the same thing as the last one. Let's show the tablet. Okay, so that means negative 5 goes in the chair. Let's make sure our exponents are accounted for. 4, 3, 2, 1, 0. So we're in the clear there. So then we take the coefficients, 3, 12, negative 3, 64. Oh, these look like they're going to get interesting. I think we can do it. So we get 3, that's a negative 15. What is that? Negative 3, that's a positive 15. That's 12. That's going to be negative 60. That's going to be 4. Oh, I'm there. That's a negative 20. And we get a remainder of negative 4. So what that means is that it is not a factor because we did not get 0. Okay, let's hop over to Pearson. Is it a factor? No. Okay. Okay, same thing. Let's just run it back. It should be going a little faster, right? Hopefully for you all it's going a little bit faster because all of these have been the same. Just different ways of asking the same question. So this is number 9. This is number 9. Comes from section 2.3, number 19. We have f of x equals x to the power of 5 minus x to the power of 4 minus 8x cubed plus 8x squared minus 9x plus 9. I gotta see what she sees. Hang on, I'll be right back. Why are you losing your mind? What's out there? What? Oh, you hear somebody in the hall? No, we're not home. I was just making sure she wasn't barking at something outside because we're like 4 stories up. So I'm like, hey, come on, that's enough. Hang on. No, just cut it up. No, come here. Come here. All right. Stop. All right. Let's see. Make sure we got everything. Look at it one more time. X plus 5, 4, minus 8x cubed, minus 9x, plus 9. Okay, and then we need this x plus 3. And let me shrink this down and get it on one line. Okay. I just want to move that from there to there. What's the time? I'm totally like ignoring the time. We go from 350 to 505. Okay. Okay. So let's hop over here. Let's just go like this so we know that that's showing. Okay, factor theorem, so same thing. So that means that -3 is going to go into the chair. Let's make sure every exponent is accounted for. 5, 4, 3, 2, 1, 0. So we're clear there. So we just take the coefficients 1, -1, -8, 8, -9, and 9. The 1 comes down. Diagonal we multiply because this adds to this. This, what is that? 4? It gives us -12. We get -4 this time. +12. We get 3. We get a -9, and we get a 0. All right, so then yes, it's a factor. You finally relaxing? Can you just chillax? Can you chillax? What? Thank you. So we want to say yes. Let's hop over here and go like this, and we're going to say yes. Awesome sauce. Okay, moving and grooving. Synthetic division. Let's just do it. Let's knock it out. Okay. So this is number 10. Number 10 comes from 2, 3, 21. 2, 3, 21. We have f equals x to the 5th minus 3x to the 4 minus 3x cubed plus 9x squared minus 4x plus 12. And we want to divide by x minus 2. Why do I always run out of space? So interesting. Let's shrink this down, move this over, and put it back. Okay. All right, let's do it again. Let's just show that it's so. Okay. First, we need to check our exponents. 5, 4, 3, 2, 1, 0. Okay, so we're clear there. So that means 2 goes into the chair. So what you see me doing now, this is honestly how I learned mathematics. Like, this is all I did. I just did the homework. Once you figure out like a couple of them, then that takes care of like a good portion of them. It doesn't take care of all the questions. But like once you figure out like 1 or 2, then you're like, okay, let me see if it works for the others. And then by the time... Come on. You just had to come and like be such a distraction. And by the time you finish the homework, you do it, you'll know it. It does take a little effort to figure it out initially, but again, once you get past like a few examples, then it becomes a speed trial. Now you're like, okay, well, how fast can I do it? You see what I'm saying? And then by the time you finish all the homework and exams roll around, it's the same thing. The exam is the exact same thing as the homework. It's just a little bit different environment, right? But that was my experience, and so and it worked. It worked through maybe about half of grad school. Grad school it takes a lot more effort because the homework is not enough. That's one level, but then you have to like go deeper. And I was just like, I'm done with this. But it'll get you a good portion of the way just simply doing the homework that teachers provide. That usually gets you a good portion of the way. Not all the way, but it's a good portion of it. I think our exponents were fine. Okay, so let's take the coefficients. Let's see. So we have 1, -3, -3, 9, -4, 12. Let me see. If we're degree 5, we should have six things here. 1, 2, 3, 4, 5, 6. Okay. So let's do our synthetic division. The 1 comes down. That's a 2. That's -1, -2, -5, -10, -1, -2, -6, -12, and indeed we'll get our 0. So then that would be a yes. Okay, so we're gonna hop here, here, and we say yes there. Awesome sauce. Okay. Find a k such that, oh, okay, this is a little interesting. Okay, now we get to some a little bit different. Okay, let me give myself a little bit of space. This is question number 11, número 11. ¿Habla español? Sí. Habla español un poquito. Anybody speak Spanish here? Number 11. All right, so it says find the k. I'm going to say find k such that, that's not that. Come on. Such that, we got, let's see, this f of x equals x cubed minus kx squared plus 9 has x minus 3 as a factor. X minus 3 as a factor. Okay. This will be fun. Let's hop over here. Let's show this for the people at home, for everybody. Okay. So if x minus 3 is going to be our factor, that means 3 goes into our chair. I think we are missing some exponents. 3, the power of 2 is there. We're missing power of 1, so we need a placeholder. Now let's just do the same thing that we've been doing. Coefficient is going to be a 1. Then we get this negative k. Let me think about it. So then we need a placeholder, which is this guy. Okay, I think that's all that we needed. Now, since we had a degree 3, we should have 4 terms. 1, 2, 3, 4. So we're clear there. So now, we know we want the remainder. Since we want it to be a factor, we want the remainder to be 0, right? We know we want to finish with 0. Okay? Let's try to fill in what we have. So the 1 comes down. 3 times 1 is 3. If we add, we're going to get what? 3 minus k. If we multiply, let's see, if we multiply, we're going to get 9 minus 3k. If we add, okay, so now we have an equation, right? So what this means, let me see, 9 plus 9. If we have 18 minus 3k, that should equal 0. So if we add up that last column, 9 plus 9 is 18 minus 3k, the answer needs to be 0. Wait a minute. Wait, I think I missed something. Let me back up, because I think I see something where I missed. Hang on. Let me get rid of that. Let me back up to here. Let me get rid of that. Okay, right here. So 3 minus k was 3k. We multiply 3 times 3. That's going to be 9 minus 3k. We add, we get 9 minus 3k. Now we need to multiply again, right? 9 times 3 is 27 minus 9k. Now we're ready for our equation. I think somehow I missed the 0. Okay. So now if we add, what is that? 9 times 4, so that's going to be 36 minus 9k needs to equal 0. All right, so now if we solve the equation, add the 9k on both sides, we get 36 equals 9k. Divide both sides by 9, k equals 4. All right? So if we let k be 4, we should get our desired result of 0. Now we could check, like we could let k be 4 and then do synthetic division again and make sure we get 0. Let's do that. Let's do that really quickly. I'm going to do this in green. I'm going to say a check. Quick check. All right, or we could put it in our calculator as well. Let's do both. So if we do synthetic division, we're going to have 1, it should be -4, 0, and 9. If we do synthetic division, the remainder should be 0. 1, 3, -1, -3, -3, -9, and indeed we get our 0. Okay. Okay. it shouldn't be any need to check this in the calculator since we checked it in synthetic division and we got the desired result. Let's see. So we said let k be 4. Let's hop over to Pearson. Let k equal 4. Cross our fingers. Let me see. 3 is the chair. Simplify. K equals, find k such that, let me see, what do we miss? K equals 4. How's 4 not working? What are we missing? Let's see. X cubed. Oh, kx squared. We got that. Oh, I see what we're missing. Dang, we did a lot of work. Okay. I wrote down the question wrong. So we got the right idea. We wrote down the wrong initial question. So let me get rid of all the stuff we don't need, which is all of this. Delete. Let me make some space and move this over. And I'll highlight what I'm missing. So what I'm missing is this kx, this guy here. I did it in purple. Okay, let's hop back over and make our corrections. Okay. Yeah, I think we found the error. Okay. So let me see the time. Okay. Thanksgiving to visit and finalize the error. Relocate. Okay. What's today? Today's Thursday. All right, let's try this again. So if we put 3 into the chair, let me see. We got 3, 2, 1, 0. So now all the exponents are accounted for. So we take our coefficients. 1, let me see, 1, negative k. Then we have a positive k. Then we have 9, right? Now let's do synthetic division. 1 comes down, that's a 1. We get 3. We get 3 minus k. We multiply, that's going to be 9 minus 3k. We add, that's going to be 9 minus 2k, if we combine like terms. We multiply, that's going to be 27 minus 6k. Oh, that's not a k. Minus 6k. And we add, that's going to be, okay, let's back up. And we want the remainder to be 0, right? We want the remainder to be 0. So now we can make an equation from that last column. That means that we're going to have 36 minus 6k should equal 0. Okay, now if we solve for k, so then we get 36 equals 6k, divide both sides by 6, k equals 6. Okay. All right. Let's just check again like we did last time. Matter of fact, since the last one we did it, let's do this one. I'm tempted to put it in the calculator, but let's. I'm just gonna do synthetic division again. Let's do it in the calculator just to be a little different. So what I'm gonna do is here. Looks good. Go like this. Okay. Let's show the calculator. Okay. So my y equals, I'm going to type, let me see, we have x to the power of 3 minus 6x squared plus 6x plus 9. We're going to quit. And so when we plug in 6, we should get 0. So I'm going to call on that function that we just did, that we just inserted. We're going to let x be 3, and the result should be 0. Okay. So let's just check it in Pearson. Let's hop over to Pearson. We got k equals 6. Okay. All right. See the time. I think we end at 5:05. Let me do like, are there any requests? Have you guys like, if there aren't, let me do like 1 or 2 more. I'm going to skip this because it's similar to what we just did. So we were able to do about 11 or so during class. Factor theorem to check whether this polynomial is a factor of this. Find the remainder. Let's skip this one. Trying to see if there's anything interesting I can find. Potential zeros. Let's do this one really quickly. So this is number 15. So number 15, this comes from section 2.3.35. It's not a 35. 35. Do not attempt to find the zero. So we just want the possible zeros, right? So we're going to do f of x equals, we got this 3x to the 4 minus 2x cubed plus x squared minus x plus 1, right? So let's hop over to the tablet. Like this. So this is the rational zero test, right? So they're asking us to do p over q, where p comes from the factors of the constant term, which is just 1 in this case. So on top we're going to have plus or minus 1, and the q comes from the factors of the leading coefficient. So it's going to be plus or minus 1 and plus or minus 3. On top we just have plus or minus 1. So then the possible rational zeros are going to be plus or minus 1 and plus or minus a third. Just those 4 answers. Okay. So we're not saying that these are the zeros. We're saying that if this polynomial has any rational zeros, it's going to be one of these 4. Okay. Let's hop over here. So it should be 4 answers. What's the difference? Yeah, it should be D. Let's go D. Okay, let's go time. This one is similar. Matter of fact, it should be the same thing just with the 7. I'm going to go with this one. Find the zeros. Okay, let's do this one. We'll make this one the last one. So this is question number 17. So number 17. This comes from section 2.3, question 39. I'm going to say find all zeros. It says find all rational zeros. Find all rational zeros. Okay. So we have f of x equals, we got this x cubed. I guess since we only made it through about half of this, we could do the other half on Friday. We'll see how we feel. X cubed minus, because usually these go a lot faster, 9x squared, but sometimes they don't. Oh, that must be for the next class. That has to be for the next class. I think it's the next class. I'm just going to let that be for now. Yeah, I'm going to just let it be. Plus 23x minus 15. Okay. We're going to find the zeros. Okay, we're going to do a few tests here. Let me show the tablet. Okay. Let's start off with the rational zero test. So our P over Q, that's going to be basically the factors of 15. The leading coefficient is a 1, so the denominator is 1. So we only have the factors of the constant term. So that's going to be plus or minus 1, 2, 3, right? 3 and 5, 4. Then I think it's 5 and it's 15, right? These are the possible rational zeros. We can also do the Descartes rule of signs. Descartes rule of signs. Right? The Descartes rule of signs tells us the number of possible positive and negative zeros. So let's just do this really quickly. So if we have f of x equals x cubed minus 9x squared plus 23x minus 15. If we count the sign changes, we have 1 here. We have a second one here. We have a third one here, right? So what this means is that we have either 3 or 1 possible positive zeros, all right? So we might have 3 positive zeros or 1 positive zero. And then for the negative zeros, we evaluate f of negative x. So first I'm going to replace x with all the x's with blank parentheses. And inside the blank parentheses, I'm going to put negative x. Negative x. Okay? So then if we simplify, the first one is going to become negative x cubed. That's going to stay as negative x squared. Negative 23x minus 15. There are 0 sign changes, so there are 0 possible negative zeros, right? So what this means is that we can ignore, we're not going to have any negative zeros at all, right? We shouldn't have any negative zeros. There were no sign changes. So that cuts our rational zero test list, that cuts this list at the top of the screen in half. We don't have to test any of the negatives. So we only need to test the positive. I'm just going to go ahead and start off with number 1. I'm just going to put 1 in the chair. Let me check my exponents. 3, 2, 1, 0. So we're clear there. Let's take the coefficients. 1, negative 9, 23, and negative 15. Let's test it and see what happens. Let me move this down to the next page. Okay. 3, 2, 1, 0, 4. Okay. So the 1 comes down. 1, what is that? Negative 8, negative 8, 15. 15, yay, we found a 0, right? So this is called the depressed equation. Since we started with a degree 3, at this stage, this is now a degree 2, right? We said 1 is a 0, so that means in factor form, we're going to have x minus 1 times x squared minus 8x plus 15 equals 0. So let's go ahead and see, can we factor that trinomial? Can we factor this guy into something like this? We're looking for 2 numbers that multiply to give us 15 and add to give us negative 8. Let me see, 5 and 3, right? Negative 5 and negative 3. So we're going to say x minus 3, x minus 5. Notice negative 3 times negative 5 is a positive 15. Negative 3 plus negative 5 is a negative 8. All right? So then the 0 factor property, we get the zeros are 1, 3, and 5. Notice they're all positive, no negative zeros. We could test, but just for the sake of time, because I think we're out of time, yeah, I'm going to get you guys out of here. I'm just going to check it in Pearson. We got 1, 3, and 5. The set of rational zeros. Find the zeros. Okay. We got 1, 3, and 5. Cross our fingers. Awesome sauce. Okay. All right. So I'm going to go ahead and load. Let me hop back over here. I'm going to go ahead and load a copy of the notes that we were doing. If there aren't any burning questions, I'll see you guys, see you brothers tomorrow at like 4 o'clock. Okay, guys. Take care. Enjoy the rest of your day.